Viewers, welcome to the channel. Let us start from our first lesson, that is the equations of motion. In physics, what is an equation of motion? An equation of motion is that which relates any four of the following five quantities. They are the initial velocity, usually we represent it with vi, the final velocity represented as vf, acceleration represented by a, distance moved by a body represented by s, and the time taken to cover some distance is called t. Now there are three famous equations of motion. Viewers, let us discuss them one by one. Coming to the first equation of motion. It is the mathematical form of the equation, that is Vf equals to Vi plus At, or in some cases it is also written as V instead of Vf and U instead of Vi. So in some books you will find it like this: V equals to U plus At. Now what are these variables which are used in this equation? Vi or U, it represents the starting or initial velocity at any given first time. Vf or V, it represents the final velocity or velocity at some later time. Similarly, A in this equation represents the acceleration. Students of physics very well know that what is an acceleration. Finally, the time t represents the time. Viewers, it is known as the famous first equation of motion. Now, here it is second equation of motion. It is written as S equals to VIT plus half AT square, or in some books you will find it like this: S equals to UT plus half AT square. Now the terms involved in this equation are Vi or U, it represents the initial velocity. Vf or V, it represents final velocity. A represents acceleration and T represents the time taken. This equation usually used to find the distance traveled by the body if its initial velocity, acceleration and time are given. The third equation of motion. Viewers, it is the mathematical form of third equation of motion. 2as equals to Vf square minus Vi square, or 2as equals to V square minus U square, where again Vi or U represents initial, Vf or V represents final, and A represents acceleration and T represents time. It is known as third equation of motion. Now, where we use these equations of motion. These equations of motion are used in solving the daily life problem related with motion. Students, you know, we observe motion everywhere around us. We see the automobiles moving on the road, we see the ball is rolling in the playground, and we see the birds are flying. So we come in different situations. We want to know what will be the speed after some time, what will be the distance moved by the body, and such situations. To find the values of these things, we use these equations of motion. These different equations will be used in different situations. It depends upon which values are given and which value is asked. So, you know, there are four variables in each of these equations. So out of these four variables, any of the three variables will be given and fourth can be calculated by using any suitable equation of motion depending upon the situation, which quantities are given and which has to be found. All values should be in system international units. Students or viewers, it is very important. When you are applying an equation of motion and we put the values of different variables, keep in your mind that all the values should be in standard system international units. For an example, if we are using first equation of motion contains the four variables: velocity, time, acceleration, and final velocity. So the velocity should be in meter per second, time should be in seconds, and acceleration should be in meter per second square. When you are inserting the values, be careful about the units of the given quantities. Now, for example, let a car starting from rest. Here is a word, starting from rest. What does it show? It shows that the initial speed is 0. So, by reading the statement of the question, first of all, we will get the information provided in the statement. And we collect these informations, and this is called data. First of all, we will collect the data from the given statement of a problem. So I again read it, that a car start moving from rest, accelerates at 5 meters per second. Now, start from rest means its initial velocity is 0 and accelerates at 5 meters per second square. It should be square. 5 meters per second square means acceleration is given. What is asked? What will be its speed after 10 seconds? Again, time is given. So we are asked to find the speed at a later time, means Vf. We have to find Vf. Now, after carefully studying the statement of the problem, we know that some values are given. Vi, initial velocity is given, A is given, and time is given. We have to find Vf. It is very much clear that we will use first equation of motion here, but keep in mind that all the values should be in standard units. Similarly, if in the same problem it is asked how much distance it covers in this time, here we will use the second equation of motion. So, where you will use these equations, it depends upon the situation in which values are given. Now, let us consider another example in which if a car moving with a speed of 10 meters per second comes to rest. Again, look at this, comes to rest. Indirectly, here final velocity is given in a distance of 10 meters. As distance is given, what will be the deceleration? Means its speed is decreasing, and students of physics know that when speed or velocity decreases, that is known as deceleration. So, in this situation, we will apply the third equation of motion. Look at this situation, time is not provided. In first two equations, we need time. So third equation, without time, we can calculate acceleration provided we are given the values of initial velocity, final velocity, and distance moved by the body. So viewers, we can use these three equations of motion in number of situations depending upon which values are given and which is to be found. I hope the point is clear. Now, there is another type of motion that we usually call motion under gravity. Galileo was a scientist who showed and experimentally proved that whenever something falls freely under the action of gravity, it possesses same acceleration. It falls with the same acceleration, and that is known as acceleration due to gravity. Its value is same, does not matter whether the falling object is heavy or lighter. So the value of this constant acceleration is 9.8 meter per second square. Usually it is rounded off to 10 meter per second square, represented by small g and known as acceleration due to gravity. So when we apply these equations of motion for a falling body, we will replace the linear acceleration with small g. So the equations of motion for freely falling objects will get this new form. First equation of motion, Vf equal to Vi plus Gt. Instead of A, we use G. Now, this value will not be given in the statement of the question because we know that it is constant. Its value is always, as I told you, 9.8 or 10 meter per second square. Similarly, in some books you will find it like this: V equals to U plus Gt, where V final velocity, U initial, G acceleration due to gravity. You know its value, 9.8. Again, I repeat it, 9.8 meter per second square, or rounded off to 10 meter per second square. T is the time. Similarly, in second equation, instead of using S for distance, we use H. H for height through which the object falls, or the height to which it rises when it is thrown vertically upward. In that situation, we use second equation for freely falling object, H equals to Vi plus half Gt square, or H equals to Ut plus half Gt square. Similarly, the third equation of motion for a freely falling object becomes 2gh equals to Vf square minus Vi square, or 2gh equals to V square minus U square. In some books you will find the pattern like this, or you will find the pattern like this. Viewers, this is all about the equations of motion. It is the basic knowledge, may be useful for school students, high school students, and for general viewers. I hope you will be benefited by listening such tutorials. Thank you, viewers, for providing your time to see the video. If you think it was useful, do subscribe the channel. Otherwise, I am sorry for wasting your time. Thank you.